everybody. A lot of you are new. Hiya, my name is Lara. I am running this science communication company called Theatre of Science. Thank you for finding me. We've been here every single week since the first lockdown. You've always got to bring stuff with you. We do a interactive activity. We delve deep into the science of something, and we do a Lego story time, which is at the end. Today's show is a little bit different because we're doing loads of activities. So I looked online for science firework models kits, and there were two, and I didn't think they were very good, so I made up my own, and now I've practiced and tweaked it. I actually think that the other two are pretty good as well. So what we're going to do is we're going to look at all the firework models there are out there, and then we're going to judge them harshly, okay? But first we need to talk about what a model is, and we need to talk about how a firework works, and then you can decide whether these models are good. Okay, so first of all, when you say model in normal English, then you sort of usually mean just like, I don't know, like this. You usually mean like just a thing that looks a bit like another thing, maybe a small version. But in science, a model is something that helps us understand how something works. I'll give you an example. I did this in my volcano lesson, but it's a good one. I live in York forests. If you said to me, Lara, how do I get from this beautiful independently run cake shop Betty's to York Minster, the largest Gothic cathedral in Northern Europe, and I gave you this, you'd be like, what? Whereas if I gave you this, you'd probably be like, oh, yeah, okay, thanks. So just straight down Stonegate and you're there. So a map is a model because a map helps us understand how something works, but being really complicated or being realistic doesn't necessarily mean that a model is good. A good model helps us understand something really well. Ah, good, some people can hear me again. Hello. So we've been talking about what a model is, guys, and how a model just helps us to understand how something works. So when I say firework model, I'm not talking about like something with paper made out of a Pringles tube. That said, I thought that might be quite a good way to just explain to you how a firework worked before we got on with our activity. So here is a firework model that I've made. You'll probably be familiar with some of the bits. A firework, we're going to just look at a rocket today. So a rocket has got this fuse, which is just a thing that burns quite slowly, so that when you've lit it, you've got time to run away. And then the fuse burns up and up and up to something called the lifting charge. The lifting charge is quite big particles of gunpowder, and they're big so that they burn quite slowly, because that lifting charge has got to burn long enough to get the rocket really high into the air. Now, some of you who are a bit sciencey or really getting into this stuff, you might have heard of Newton's law, that is, for every action there is an equal and opposite reaction. So if you just light some gunpowder on the ground, it just goes, nothing happens. But if you pack it into a tube where the only way it can explode out is this way, then the gunpowder, the explosion, pushes out on the air and there is an equal and opposite reaction. The air pushes back, and that's what sends our rocket high into the air. And then above the lifting charge we have this, which is the bursting charge. This is gunpowder packed really tightly, and it's surrounded by, I'm totally blanking on their name. Oh, stars! Yeah, they're called stars. They don't look like stars, they're just little peas, but they're made out of all different chemicals that we discuss later. And they burn with different colours. And eventually, when it gets high enough, this bursting charge explodes, sends all these stars spraying out, and these little stars are like balls of sort of gunpowder and different chemicals, and they get set on fire by the bursting charge, and they explode, and that's what you see. It's that lovely like circle of little stars. So that's a firework model to start with, but I think we can do better than that. Let's go for it. So the first experiment we are going to do, activity we're going to do, is the milk one. So you will need some milk, some food colouring. Yellow one doesn't work well, it like all spreads out, so you might want to sit on that for a bit. You will need 3 spoons and a plate. I want to show you this because I'm pretty proud of this. I made you a little viewing station. See, how good is that? I'm going to put my plate under there. But then you're going to go into here. There we go. So what you do is, this experiment was one that did really annoy me, because I was like, that's not a firework at all, but I think I might have changed my mind. So pour the milk onto the plate. There we go. Hello, Dominic Miller, I didn't see you there. And then get some food colouring and just put a tiny little blob onto a spoon. Thanks, Yaya. Nice to see some positive comments. I know some people are upset that they can't hear me properly. And just pop that, let's just stick it in the middle. Boop. There we go. And then I'll put some blue in as well, but we don't want to use too much. I think, if you can hear that, I think that's the sound of my two-year-old having a good time. It's very difficult to tell at the moment. I'll put that in as well. There we go. And then all you do is, you get the tip of a spoon and you dip it into some washing up liquid. I've got mine in this little egg cup. It's good this, isn't it? I'm going to use this little viewing station again. And, oops. And then all you do is stick the washing up liquid into the middle of the food colouring. And this is the classic online firework activity for kids. You ready? Woo! Yeah, Albert, I think gel food colouring might be better actually. And there you go. If yours looks better than mine, can you please send me a photo and tell me what you did? Because this is, some of the ones you see on YouTube look amazing. This is what I've managed to get. It's pretty good, isn't it? It's pretty good. Should we do it again? Because what I want to see, right, is that the cool thing about those stars in that firework that I showed you is that they, if you pack them in a certain arrangement, that's the shape that you get. So you could just put them in a circle and then you'd see a circle in the sky, but they've got quite clever now, and they can pack them in all different shapes, like they've done a peace sign, or you could pack the stars around the bursting charge in a way that they look like a smiley face. So if this is a good model of a firework, I want to see, if I put my food colouring in a certain shape, will it send, oops, gross, sorry, little hair there, will it send, if I put my washing up liquid in right in the middle, will it send it into the same like pattern but further out? You see what I mean? Shall I try? I haven't done this before. I'll try a smile. Maybe that's a bit optimistic. All right. It's not terrible, is it? I mean, it's really creepy. Yes, Louise! Well done. It is just like the pepper. Yeah, I'm going to talk about it in a minute. Yes. So Louise is quite right. There's another demo experiment you can do where you use water and pepper and you just do the same thing. Okay, here we go. I'm going to put it in the middle. Let's see if this keeps its shape. Ah, yes. So creepy. Looks like the Joker from Batman. That's not bad, is it? So that's sort of a bit like how a firework works. So a firework, these red dots would be the stars, and the washing up liquid would be the bursting charge. And when that explodes, it all gets sent outwards. So, not the worst model. Oh, Hannah, eco washing up liquid. I know, I feel awful that I've had to get a bottle of bog standard fish killing stuff in for these activities. So what is going on there? Let's look at the science behind that and then we'll do another one. Right, so what is going on there? And is the science behind that anything like a firework? So, if you've been coming to my home ed lessons, my chemistry lessons, you know that water particles are what we call dipoles. Basically just means that one side of a water particle is a little bit positive and one side is a little bit negative. If you don't know what positive and negative means, you can think of water particles as kind of being like tiny little magnets. And on the surface of the water, they all line up. They're very slightly attracted to each other. And that's what causes water surface tension. You know how like the sort of surface of water always looks like it's kind of got a film on it. That's water surface tension. And milk is basically just water. So the whole surface of the milk is lined up like that. And the food colouring doesn't really make a difference. But when you put washing up liquid in, washing up liquid breaks these very delicate little bonds. And what happens is the particles rush to where there are bonds. So the reason is, if you were going to be really technical, then I think what happens with this is that the particles are pulled towards where there are still bonds. Obviously a firework, the stars are pushed out by the explosion, whereas here the little stars, the food colouring is pulled. It's pretty technical though. Why else is it a good model or a bad model? Well, it involves colour, doesn't it? And it involves colour spraying outwards. Like I say, where's my terrible model? If you pack these stars in a different shape, then the bursting charge, they hold their shape, and it does hold its shape. So you guys decide, please. How good a model of a firework is that? Give it a mark out of 10 for how cool it is and how well it explains fireworks. And then we'll do another one, okay? Let's do the one with the oil. Right, I'm just going to make sure that I don't spill milk all over my office, because you've probably seen that it's already not the tidiest place. So for this next one, I mean, you can just keep playing with that if you like. But for this next one, you need some oil, and however much food colouring you've got, put that many, so I've got 3 food colourings. So I've got 3 little jars with oil in. So if you've got 2 food colourings, you need 2 little cups with just a few tablespoons of oil in each. Put my little viewing station out of the way. Yeah, so you need, this is the one where you need the jar of warm water and little cups of oil. And what you do is, oh, hello Matthew Jones. Henry thinks it's a good model. Whoa, James is giving it 10 out of 10. James, what if this one's even better? What are you going to do? Laura says 8.5. All right, Leanne's saying 7. Wow, this is a popular model. Natasha's like 5. Yeah, well, we'll give you something to compare it to. Okay. All right, people. Whoa. Cool says Yaya 9. Realistic 7. Okay. Let's press on. Now, put a few tablespoons of oil into your little jars, and then add a fair bit of food colour in. This is another one where I didn't get it to work at all, and then with a little bit of practicing and tweaking and finding out what works best, hopefully it's going to be okay now. So I've put my red food colouring into my oil, and what seems to work best is if you don't mix it in so that it's too small. Oh, Helen's giving it 5. All right, Helen. Here, I'll show you this, because this seems to be important. So can you see that you end up with these little like balls of food colouring suspended? You want quite big balls like that. Not the tiny little balls on that side, but quite big blobs. That's what we're going to be putting into our water. In fact, I'll take you down here now. There you go. I'd say feeling pretty prepared this morning. This is your little firework viewing station, my enormous jar of water here. So put some, looks like wine. Yeah, Rebecca, sometimes it is, but not today. So put your warm water into a jar. It's a bit bubbly, isn't it? And let it settle, because you don't want any, you don't want to create like a hurricane. I mean, it would look cool, but it's not what we want to do today. Yeah, gel food colouring's good, Alba, yeah. So mix your food colourings into your jars, into your oil, sorry. There we go, yeah, and you just want a few blobs like that. I've fallen out with my red food colouring. I think I'm just going to stick to, have you all seen that, guys? Yeah, so you've got some blobs of food colouring, and what we're going to do in a minute is we're going to just very, very gently put these blobs of food colouring into the warm water. I'm using the biggest jar that I could find. 10 out of 10, says Amelia. You guys, it's not fair, is it really? We should wait until we've done this one. So I'm going to very gently, but quite quickly, put a teaspoon of each of my food colourings into this jar. Here we go. Oops, that wasn't very gentle, was it? You can see better than me. What can you see? What can you see? Oh, okay. What do you think? There we go. There's the blue. Ooh! So, does that look like fireworks? You do the same thing. Put your food colourings. Oh, yeah, that's pretty good, isn't it, actually? I had a big downer on this one. I was like, what are these people talking about? But it does keep giving, doesn't it? Wow, so even now, fireworks are still happening. Hey! Okay. Is this model of a firework better? Dominic's just straight in there, 10, boosh, good. Jessica thinks it looks like a lava lamp, 7. Yaya's going 7.8. Lucy says 0 out of 10. Lucy, are you judging mine 0 out of 10? Or are you saying that yours didn't work? So, why is this like fireworks? Well, they're 3D, aren't they? They're 3D, so that's better maybe than the milk one, which was flat. It was only 2D. They keep coming. That's pretty good. Like, I'm not having to put any energy in, although I suppose that was the same with the milk one. Like, you just tap it and then it does move on its own. Wow, this has really divided people. I have to say, I quite like this now. But why is it like a firework? So, blue is apparently very difficult to make with fireworks because you've got to heat up copper oxide to exactly the right temperature. And the blue one on this was very easy to make, just the same as the others. That's one reason why this isn't a very good. Angela shouts, "Mine went into water balls!" Angela, I don't know what that means. I don't know if you're excited or furious. Lucy's didn't work, it just sunk. It just sank, really? Lucy, are you using like posh food colouring? It shouldn't make a difference though. Leanne's floated. Yeah, if it's floating, if you wait for ages, then it does sometimes fall and burst. So what do you think? Yeah, marks out of 10. So how that one works is, sorry, regulars know I'm just jabbing my cracked phone to get you back now. There we go. How does that work? That's to do with density. So we talk about density a lot in theatre of science. Density basically just means how close together the particles of a thing are. So water particles are very densely packed together. The particles in oil are a little bit more spread out. And things that are more spread out, we say they're less dense and they float above denser substances. So water, more dense, particles closer together, has sunk to the bottom. Oil, less dense, rises to the top. I think what happens is that the food colouring gets caught up in the oil, so it floats, but ultimately the food colouring is the same density or similar density to the water, so it kind of wants to sink. So what you're trying to do is get the food colouring caught up in a little bubble of oil so that it floats, and when the bubble bursts, then the food colouring is released. Does it explain firework models in the slightest? I don't know. I don't think so. Apparently, the reason you see loads and loads of fireworks all together is because it is a bit of an iffy science, and they do it to mask any that don't work. So that's kind of the same. Like, one on its own would be rubbish, but you do loads. Sarah's like 10. Rebecca says 9. Jamela says 8. You lot are being very positive. You just like all these, dear. All right, well, let's do mine. The one, because I decided those were rubbish at first, I couldn't get them to work, so I did another one. This is the one where you need... So I didn't want it to make it too complicated, so you could just get your plate, use your milk plate if you like, light your match and hold it over the plate, and then what you're going to do is get a little powdered spice, and holding it very high so that you don't burn yourself. Adults, you are in charge here. I don't want any young people doing this. Sprinkle the spice over the match and see what happens. If you've got a candle, that does work better, but that's what happens to your candle. So, yeah, like I say, don't use your posh Christmas candle. But here's what we're going to do. I'm going to light my candle. I'm going to use a candle because I can't possibly read comments and talk about science and sprinkle spices onto matches as well. That is a recipe for a disaster. Okay, here we go. Bring you down here so that you can see my fire. So, yeah, kids, you're not lighting the candle, okay? You're watching and judging harshly. There we go. Trying to pretend that my study isn't a mess. So that's all you do. So make sure that obviously you hold your hand far enough above the candle that you don't get burned, and just dribble your spice on and see what happens. See if you can listen as well. Dylan, you're going to film this for your homework. Nice, that's some cool homework. Okay, so I'm sprinkling now. Can you see that? Can you hear that? Wait, get a bit closer, you guys. Oh, shall I just keep going until it goes out? Should we go a bit crazy? Oh, oops, okay, too crazy. Well, you can do it yourself. What do you think about that one? Was that a good firework model? Is that a good model of a firework, the Sparky Sparks? Well, it was hot, and fireworks are hot, so that's one way that it's realistic. It wasn't colourful, so I'll tell you a little bit about the chemicals that those little stars have in them. So if you saw my Northern Lights lesson, actually, it works the same way. So I won't go into it in huge amount of detail, but everything in the world is made of atoms, and atoms are little particles with other little particles called electrons whizzing around them. And basically, when atoms get hot, they get excited. Their electrons get excited and they jump around. And as they jump up and down, they release a certain colour, and all different atoms release different colours. It's like a fingerprint, they're all different. So magnesium and aluminium produce a white light. Some of these, if you look these up, if you Google like homemade fireworks, some of this stuff, these chemicals, you can get from like garden centres if you want to try that again and be a bit more fancy. So have a look at this list, particularly people who have been to my homemade chemistry lessons on a Tuesday at 1:30. Some of you might be getting really excited and be like, sodium chloride, that's just salt. Oh my goodness, why aren't we sprinkling salt onto this candle? That would be amazing because sodium chloride makes a colour. Yeah, it does. Magnesium and aluminium produces white. Strontium chloride produces red. Barium acetate is green. Copper oxide is blue. Sodium chloride, salt, burns yellowy orange. Oh, what did you do on Fit Science today? Oh, we made orange fire. It was amazing. So if you want to sprinkle some salt on your candle later, you do that. Tell me how impressed you were. Orange fire. Somebody's... Anyway. So the colour, not so much. But, oh, the other thing I didn't tell you about the bursting charge, this charge in the middle, and the stars, is they have very, very fine grains. You remember I said that the lift charge is really big particles because you want it to burn slowly because you want the firework to get into the air. The stars are the opposite. You want them to be really, really small so that they burn really fast, like really bright. So that's why I said you had to bring a fine powder. You'd like drop a cumin seed onto this. It's not going to work. It's just going to smell horrible like cumin and it's going to take ages to burn. But the finer the powder, the smaller the particle, the faster it all burns, the faster it can react with the oxygen around it, and the brighter it gets. So I am very biased because this is the one that I made up because I thought the other two were rubbish. But that's one way that this is like a firework, and it's hot, and it does give off light, and something burns. So, I don't know. You can, I think it, do you know what? I think probably actually, if we're being totally honest with ourselves, the model that explains a firework the best is this Pringle can with a bit of wool sticking out of it. But that's not the point, is it? The point is to have fun and make things move. Right, what time is it? Is it story time? Oh my goodness me! Did you guys have anything to do today? It's story time, guys. Just drop a tin can on the candle for white light. Okay, I'm not... I cannot be responsible for what you lot are getting up to now. This is the story of two brothers. Let's call them Jeff and Mark, because those are their names. When Jeff was a teeny little baby, his mum had him when she was 17, and his dad was part of a unicycle troupe, owned a bike shop. Before Jeff was 1 year old, his mum and dad had parted ways, and when Jeff was 4, his mum remarried a Cuban chap who'd just moved to America, and they had little baby Mark, and the brothers were united. So we'll focus on Jeff. Jeff, growing up, was very, very into science, just loved science, loved computers. He actually nearly became a physicist, but then he had a really good idea for a website. And on a very long car journey, he wrote down his business plan for this website, and then when he got home, he set up the website in his garage. Now, it's 1994, so people didn't know a lot about the internet, and Jeff needed money to set up his website. So what he did was, he went to all his friends and family, about 60 friends and family, and said, hey, look, I've had this brilliant idea for a website. If you give me some money so that I can set it up properly, then I will give you some shares. I'll share the profits with you. Now, we don't really know much about the internet, so we don't know how it's going to work. But, you know, hopefully you just trust me. Most of his friends and family said no. Some of them don't talk to Jeff anymore. They find it too painful, because if they'd given him a little bit of money to start his website, they would now have in the bank £500? Did they miss out on £5,000? They'd have £5 billion. The website that Jeff had thought of was Amazon. Jeff is now the richest human being on the planet. He is worth $200 billion. Probably can't picture that amount. And it's been a very good year for Amazon. So Jeff broke records on a day this year by earning £10 million in one day. That's 30 times what the Queen has in a day. Imagine getting 30 times what the Queen has in one day. You can't imagine it, can you? Between March and July, shares of Amazon went up 70%. Now, Jeff is a little bit controversial. He's got loads and loads and loads of money. But he's got, like I said, he's got $200 billion. He's given $2 billion to charity. So that's like if you had £10 and you saw someone who really needed help and you gave them 10p. It's the same percentage. So you can decide. It's his money, isn't it? That's something for you to debate later with your family. It's his money. Should he have to give it to charity? We don't know. But anyway, I did say that this was the tale of two brothers. So let's have a look at the second brother. What is Mark doing? Well, Mark lives in New York and he works for a charity who fights to get families out of poverty. But as Mark says, when he's not fighting poverty, he's fighting fires. Do you see the tenuous link here? What an obnoxiously nice guy. Mark is a volunteer firefighter. Now, what being a volunteer firefighter means is that when a fire happens, all the professional, proper firefighters race to the scene, and the volunteers get to the fire as fast as they can, and if there's any job left to do and they're early enough, then they might get something to do. Mark does a TED Talk where he talks about one particular fire where he got to the scene really early. And he says when he arrived, he felt so sorry for this poor woman that he saw talking to the fire chief. Her house was on fire, it was pouring with rain, and she didn't have any shoes on her feet. He said she was in a real stress, so he went over to the fire chief. He couldn't believe it. Couldn't see any other volunteers there. He went over to the fire chief to see if there were any jobs that he could do, and some other volunteer just nipped in front of him, and Mark had to stand there and listen as the fire chief said, thank goodness you're here. Can you please go into this woman's house and rescue her dog? Mark says, I couldn't believe it. Like, here's this guy who's probably just a lawyer or something, and he gets to spend the rest of his life saying that he rescued a dog from a burning building because he got here 5 seconds before me. So anyway, this guy goes off to rescue the dog. And then Mark goes off to the fire chief and says, what can I do? And the fire chief says, can you go into the building and get this woman a pair of shoes? Kids, I need to say here, please don't go into burning buildings for anything, especially not shoes, but apparently the fire was nearly out, so Mark says, oh yeah, all right, and off he goes. There we go. So Mark bursts in to the burning building, and he goes all the way up the stairs. Like I say, the fire was nearly out. Don't go into burning buildings unless you're a specially trained officer. He gets the shoes. He comes all the way downstairs again. He says he meets who he calls like Lex Luthor, smug dog guy, in the hall, and they both come outside again. And Mark says, you know, pretty obviously, as you would expect, everyone is very, very excited to see the dog, and no one really pays much attention to the shoes, and Mark feels a bit sad about it. And then, a week later, Mark changes his mind, because a week later, the fire station gets sent a letter by the lady whose house burned down, and she thanks them all for their incredible service. But the thing that she mentions in the letter, the one fact that she picks up, is that she couldn't believe that someone even went into the house to rescue her shoes. And Mark says, I realised then that in my job as a fireman and in my job fighting poverty, I see a lot of big and small acts of grace and kindness, and I realised that they all matter. And his message is, don't wait until you've made $1 million to make a difference in someone's life. Give someone some food or clean a park. He says you can't save a life every day, but you can affect one. Save the shoes. That is Mark's lesson. Oh, and also, you remember I said that Jeff asked all his friends and family if they'd invest. Yeah, Mark, he invested in his brother's business. So, there you go. Kindness does pay off. Mark, billionaire, fireman, poverty fighter. What a guy. And that is the end of story time. Louise, why were the shoes upstairs? I don't know. Bedroom, I guess. I don't know. I do a lot of research, you know. I don't know why the shoes were upstairs. Go and find out and tell me. Right, folks, thank you so much for joining me. That is the end of my Bonfire Night special theatre live show. If you enjoyed that, it was so lovely to see so many new people here. It's really nice to know that this, I was going to say, wasn't just a lockdown thing. It's still lockdown. You know what I mean. I started doing these during lockdown. I am a secondary physics teacher, taking a little break to raise my darling small children, but I'm doing this in the meantime. A lot of people have been saying, like, do they have to book, and like, how is it free? I sort of feel bad taking credit for it being free, because I am getting paid for this actually. I'm going to do my little advert if you don't mind. I have got a patron page. There's this website called Patreon where you can support me with £3 or £5 or £10 a month, and you get different little thank yous. So a lot of wonderful people here are doing this already. One of the thank yous that we're all excited about at the moment is if you support me with £5 a month, you get this bi-monthly magazine, and it's like proper. My husband's a graphic designer, so I write it and he designs it, and it's all like new content, and it's pretty fancy. I was going to try and sell you it. I've actually only got about 3 left. I've got a couple of last times magazine, like the 2 months ago's magazine as well. So if you really enjoyed that and you're like, we're going to keep coming and I want to support her, then you could go to my Patreon page. I think if you go on my Facebook page and click shop now, then it will take you straight there. That would be very much appreciated. Far more importantly, especially if you're new, if you could share the news about this, that would be fantastic. I'm terrible at marketing usually. That's the only way anyone knows about this, is because people have been telling each other. So very much appreciate all the shares. All the likes on my Facebook page give me like a sort of sad amount of pleasure that I should probably look into, but it's very nice seeing the numbers go up. I've got various competitions going on in my head with other businesses, although they don't know or care about that. And all my previous lockdown lessons are on my YouTube channel. So if you want to go over to my YouTube channel and subscribe, then it's sort of smarter edited versions of every lesson I did over lockdown before I got a bit too busy and lost the plot are on my YouTube channel as well. Thank you so much. I'm going to say big bye. Thank you so much for coming.